Hello, dear students. Hi. Good morning. Yes, welcome back to the chemistry class. So, in the last class, we have studied about preparations of alkanes and its physical properties, right? So, now next, chemical properties. Next, studying chemical properties. So, in the chemical properties, first one is which reactions? Substitution. Second one, oxidation. Third, isomerization, aromatization, pyrolysis. These are the reactions we need to study with respect to alkanes. Let's start with the first one, substitution reactions. Substitution reactions. So this substitution reactions. First one, halogenation. Halogenation. Nitration, sulfonation. What are the reactions for halogenation? So in halogenation, how many halogens total? 4. Fluorine, chlorine, bromine, and iodine. Fluorination, chlorination, bromination, and iodination. Simple. First, you can take an alkane. So one of the hydrogen from alkanes is substituted by a halogen atom. So this is halogenation. Now, general reaction RH. It is an alkane. Alkane, which contains one hydrogen I have shown you. So when this is treated in the presence of halogen, or reacted with halogen in the presence of sunlight. In the presence of sunlight. Preferably, the halogen is either chlorine or bromine. If iodine is used, then some particular oxidizing agent we need to take in the presence of oxidizing agent. Fluorination cannot be done because it is very vigorous reactions, very fast reaction. So therefore, either X may be Cl or Pr. I is possible, but in the presence of an oxidizing agent. Yeah, I can explain more later. So in the presence of sunlight, so Rx plus Hx. So this hydrogen is replaced by one halogen, and this hydrogen along with one more halogen is eliminated. This is the substitution reaction. Now, if you are considering first one is fluorination reaction. In case of fluorination reaction, we have to see order of reactivity. Fluorination is very fast reaction. Second one is chlorination, bromination, and iodination. Least. This is the order of reactivity. Halogenation reaction follows this order. Fluorination reaction is very fast reactions. We cannot control. Therefore, fluoroalkanes cannot be prepared by this method. Fluoroalkanes cannot be prepared by this substitution method. But alternatively, this can be prepared by halogen exchange method. If you want to prepare fluoroalkanes, then halogen exchange method. Alternatively, the fluorination cannot be prepared by this method, but it can be prepared by halogen exchange method. It is a higher concept. If you want, we can watch it now. Else, no problem. In class 1, again you are going to study. So here, first we need to take an Rx group, that is haloalkanes, where X may be either chlorine or bromine, chloride or bromide, and X is equal to. And this is treated with the metal fluoride, MF. Let us take one example, the silver fluoride, AZF. Silver fluoride. Then what happens? These two halogens are exchanged. Halogen exchange method. So this gives rise to RF plus AZX. AZX. RF plus AZX. So fluoroalkanes can be prepared by alternative method, that is by halogen exchange method. This reaction is known as Schwarz reaction. Schwarz reaction. Schwarz reaction. Definition for Schwarz reaction: it It is a higher level concept. Class level concept Allah is a class 12 concept. Fluoroalkanes can be prepared by when alkyl halide are haloalkanes. Haloalkanes are alkyl halide. When it is reacted with metal fluoride, which gives rise to fluoroalkanes, particularly fluoroalkanes. This reaction is called Schwarz reaction. Schwarz reaction. Name the last page Schwarz reaction. One word. Next. Chlorination is done by this method. Chlorination. Chlorination. So here simple. When alkanes is reacting with chlorine in the presence of sunlight, when it is heated, this gives rise to RCl plus HCl. RCl plus HCl. Chlorination reactions. Here, CH4 is an example. These reactions, I think this substitution reactions you have studied in class 10. CH4 plus Cl2. This gives rise to in the presence of sunlight. This gives CH3Cl plus HCl. If one more molecule of chlorine is used, what happens? This CH3Cl further react with one more Cl2, gives rise to yes, good CH2Cl2 plus HCl. If one more molecule of Cl2 is used, CH2Cl2 plus Cl2. Yes, good CHCl3 plus HCl. If this CHCl3 in the presence of one more Cl2 molecules gives rise to CCl4 plus HCl. Then what is the overall reaction? CH4 plus 4Cl. Overall reaction is CH4 plus 4Cl2 gives rise to CCl4 plus 4HCl. Correct? Because add these equations, CH3Cl get cancelled, C2, CH2Cl2, CHCl3 get cancelled. CH4, 1, 2, 3, 4, 4Cl2 gives rise to CCl4 plus 4HCl. Substitution reaction. Halogenation reaction. Fluorination reaction cannot be possible. It can fluoroalkane can be prepared by halogenation. Chlorination in the presence of sunlight, this reaction is possible. Chlorination. Similar to this, even bromination reaction is also possible, feasible. Bromination. Bromination reaction. Bromination. Rx plus Br2. Br plus HBr. Bromination reaction. Bromination reaction. Substitution reaction. Alkanes. If you want to iodination, iodination reaction. So here RH not X, it is RH alkane. When alkane is reacting with HI, this reaction is reversible reaction. Ri plus HI. It is a reversible reaction. The reason is HI is a reducing agent. This is a reducing agent. The product HI is a reducing agent which reduces the alkyl iodide to alkanes and iodine is liberated. This reaction will be reversed. So because of this reason, we are using an oxidizing agent. So therefore, the liberated HI is converted into other form. Therefore, product iodoalkane is preferred. This reaction is reversible. So this can be again iodoalkanes can also prepared by halogen exchange method. This can be also prepared iodoalkanes alternatively This can be prepared by halogenation method again. Rx, where X is equals to either it is Cl or it is Br, chloride or bromide. When this is treated with particularly sodium iodide in the presence of dry acetone, this gives us here these two are get exchanged. Iodine and the halogen is exchanged, and this gives rise to the product Ri plus NaX. This reaction is called as Finkelstein reaction. This is also class 1 higher level. If you want, you can note down, or else not necessary. Halogen exchange method. Fluoroalkane and fluoro and iodoalkanes are prepared by halogen exchange method. For fluoroalkane, this reaction is called Schwarz reaction and it is Finkelstein reaction. Higher level is there, but it is not for class level. Extra point is given in the book. If you want, you can note it, or else it is class 12 concept. I'll not repeat it. Yes. Now let's see the mechanism. How this reactions will happen, how it takes place. Mechanism. Okay. First one is in halogenation, fluorination, chlorination, bromination, iodination. Fluorine substitution it is very fast reaction, vigorous reactions cannot be controlled, therefore the reaction is we are not carrying. Chlorination, bromination, okay. But iodination is reversible reaction, therefore we are using an oxidizing agent like HNO3 is used, HNO3, HiO3, etc. Oxidizing agent is used. So in the presence of oxidizing agent, the reaction proceeds in the forward direction, or else the reactions will be backward. So this is about the halogenation reaction. Just here from an alkane, one hydrogen is removed and halogen is replaced. Hydrogen is replaced by a halogen. Substitution. Clear? Yes. Substitution reaction. Now let's see the mechanism, how it takes place. They explain the mechanism of halogenation of alkane, or generally mechanism of chlorination of methane and chlorine. Explain the mechanism of chlorination of methane. It is given in the textbook. So mechanism of chlorination of methane. Or not about it. Two named reaction. Finkelstein's what? Just last heading of poetry. Last page. Schwarz reaction. So total named reaction is one. First first reaction of name reaction. Woods reaction. Franklin reaction. Always electrolysis. Next section. Schwarz reaction. Finkelstein reaction. Preparation part last time deta. What's the Franklin? Savatier standards. Preparation of alkane. Savatier standards reactions. Bandita. Savatier Sanders reaction. Savatier Sanders reaction. Nickel in the presence of nickel at high temperature. Preparation of alkenes from alkenes. Bandita, Elina? Yes. Note this word. Our reactions heading is Let's complete up. Right, next heading. Mechanism of chlorination of methane. Mechanism of chlorination of methane. First one, halogenation. Mechanism of chlorination of methane. Mechanism of chlorination of methane. See, the mechanism involves three steps. Mechanism of halogenation reaction. In general, halogenation involves three steps. First one is, usually this is substitution reaction in the presence of sunlight. It takes place through free radical mechanism. This will take place through free radical mechanism. It proceeds through free radical mechanism. Now, the mechanism involves three steps. It involves three steps. Step 1. Right on the heading. It involves three steps. The mechanism involves three steps. In the next heading, step 1. Step 1. Chain initiation. Chain initiation. First step. Chain initiation. Chain initiation. This is the first step. So first, when X2, that is halogens, particularly Cl, example I have taken chlorination. In chlorination, Cl2. As you know that this is both the elements are same, the bond is non-polar. In the presence of sunlight, it undergoes homolytic bond cleavage. Homolytic bond cleavage, homolysis. So what happens when it undergoing homolysis? This results in the formation of free radicals. That is Cl dot plus Cl. Two radicals are generated. Yes, first step is over. The chlorine undergo homolytic bond fission gives chloride radical, free radicals, generation of free radical. Over first step. What do you go through reaction rate? Chain initiation means the reaction is initiated. Second step, step 2, chain propagation. Chain initiation, propagation. Now, in this chain propagation reaction, the reactions will continue. See, which reactant we have taken? Chlorination of methane. General mechanisms already you have written. CH4 plus Cl2 gives rise to CH3 Cl plus HCl, or simply CCl4 plus 4HCl you can write. That is the oral reaction. In that reaction, how the reaction will proceed? Chain initiation, first free radicals are generated in the reaction. Next, these free radicals are reaction intermediates of GOC. Reaction intermediates. Free radicals are highly unstable. Free radicals are reaction intermediates. Its lifespan is very less. Highly reactive species. So these reacts with our reactant. Reactant is methane. So methane. CH4 plus Cl dot. See, in chain propagation reaction, these are the two electrons in one bond. So one of these electrons which combines with Cl radical and a bond is formed. Which bond it is? HCl, separate out. So this gives rise to HCl plus remaining product CH3 dot. So this is which radical it is? Methyl radical. CH3 dot, because one electrons are involved in the bonding, HCl is out, and this will remain as it is on the carbon atom. CH3 dot, methyl radical. Since it is propagation step, so these reactions will continue. Now this is CH3. It may be react with, see the possibilities. Here are the possibilities only. CH3 radical, it may react with another chlorine. So in this case, what happens? Two electrons are here, one dot and this one dot. A bond is formed. The compound is CH3Cl plus Cl dot. The generated Cl radical again it may react with CH4 and produce CH3. This CH3, it may be react with another molecule of this compound. So we generate CH2Cl. Possible is that? Let's check. CH3 one is the compound CH3Cl. So I am indicating one bond CH3Cl. Either CH3 or Cl radical. Any radical. Suppose if one more radical is reacting with this compound. So what happens? This one CH bond is undergoing cleavage. So one dot and this one dot. Again HCl is removed. CH2 Cl dot. So this uses to CH2 Cl dot radical. So this reactions will propagate continue. till all the reacting species which reacts together and gives radicals. Our radicals are compounds. Yellow complete agutte till all the reactants are reacts together. So here in this step, radicals are generated. So propagation. This reactions will be continued. It propagates till the end. And at the end, chain termination step. Last step. Step 3. Chain termination. Chain termination step. In this case, what happens? Two different radicals when it meets together, which makes a bond. When two different radical combines to give the product. What are the possibilities? If suppose Cl radical combines with another Cl, Cl radical it may combine with the CS3 radical. CS3 radical it may combine with another CS3 radical, etc. Any compound. So this gives rise to the possible Cl2 CH3Cl plus C2H6. Is any other possibilities? Yes, different possibilities are also there. This is the radical CH3Cl. If this CH2Cl combining with CH3, CH3CH2Cl, but only you have taken methane. So what is the probability? Only one carbon is the product. So not more than that, preferably. So therefore, halogen is substituted. Chain termination step. In the chain termination step, different radicals combines to give the stable compounds. Stable means further which do not undergo any reaction. First step, reaction initiated. With the free radical mechanism, first step radicals are generated, chain initiation. And these radicals react with the reactants used and which propagate till all the reactants are consumed. And at the end, different radical combines to give the product. So, halogenation reaction involves 3 steps. The mechanisms involve 3 steps: chain initiation, propagation, termination. Clear? Third step, termination. Here are different radicals ಇದಾವೆ. ಬೇರೆ ಸರಿ ರಿಯಾಕ್ಟ್ ಅಲ್ಲ ರಿಯಾಕ್ಟೆಂಟ್ ಎಲ್ಲ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಮುಗಿದೋಗ್ಬಿಟ್ಟವೆ. ಈಗ ನಮಗೆ ಆಪ್ಷನ್ಸ್ ಏನಲ್ಲ. They will react together and a stable compound is formed. Stable bond. Because radicals are not generated in this step. Radicals ಬಂದ್ರೆ it is compound, stable one. It do not react with the further, so these are the products. GOC, basic mechanism part is starting in reactants which gives rise to intermediates and then products and byproducts. So reactant CH4 plus Cl2, reaction was initiated. Radicals from the intermediate, radicals are intermediate. These all are intermediates in propagation step. All these are intermediates which reacts together to give the product. So chain termination is last. This is the mechanism. So simple 3 step: initiation, propagation, termination. Initiation the radical goes through. Propagation the further reactants react, so there are no reactions. Termination the 2 or more radicals combines to give the product. Over. This is halogenation reaction complete. Next one. Initiation, propagation, termination. Next one is nitration and sulfuration. 2 more reactions. Nitration and next one is nitration. Nitration reaction. Nitration. The reaction which involves the replacement of hydrogen by a nitro group, NO2 group, is called as nitration. So in this case, alkanes, that is RH, or simply we can write RCH2H, RCH3. Any alkanes, long chain only as the R group, alkane, confusion alkane, simple RH, alkane. So in the given alkane, either it may be methane, ethane, propane, butane, other yes, from that. If this is reacting with concentrated HNO3 in the presence of concentrated sulfuric acid, H2SO concentrated. Remember, this mixture is known as nitrating mixture. The mixture of concentrated HNO3 and H2SO4 is known as nitrating mixture. This mixture is known as nitrating mixture. In organic chemistry, words that means NO2 group to be substitute. NO2 group substitution is nitrating mixture. Substitution means a replacement of this one of the hydrogen by NO2 group. NO2 group is known as nitration reaction. So for the nitration, nitrating mixture is used. Decarboxylating agent yavudu? Soda lime. Mixture the composition? NaOH plus CaO, calcium oxide. So here it is nitrating mixture. So from this NO2 is generated in this reaction. NO2, H2SO4 and HNO3, HNO3. So from this NO2 is generated. So this NO2 is replaced NO2 nitro alkanes are the product. When alkane reacts with a nitrating mixture, or simply we can call react with HNO3, it is understood, gives rise to nitroalkanes. Nitroalkanes. This is simple alkane. When alkanes reacting with the nitrating mixture gives rise to nitroalkane. Nitroalkane. And preferably this reaction is favorable in vapor phase. Vapor phase reactions are very fast. In ordinary conditions, the reactions is not feasible, but in vapor phase andre gaseous phase that means high temperature. At higher temperature, the reaction is feasible. Nitration. Next, sulfonation. 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 When alkanes undergo sulfonation, sulfonation means in the presence of oleum H2SO4 mixture of SO3, or simply in this place I can write H2S2O7. H2S2O7. This is called oleum, or it is also known as fuming sulfuric acid. Fuming sulfuric acid, or simply we can call oleum. H2S2O7. H2SO4 and SO3. So it produced by concentrated sulfuric acid. H2SO4 plus H2SO4. Two molecules of sulfuric acid in one water molecule material. H2 total H2S2OH. Sorry, H4S2OH. Total two molecules of sulfuric acid. So from this one water molecule is eliminated. So this gives rise to oleum, composition oleum, H2SO4 with SO3. So here SO3 group will be substituted. So this gives rise to the product SO3H, sulfonic acid, SO3H, sulfonyl group, alkane sulfonyl group. So here sulfonic acid, sulfonic acid, alkyl sulfonic acid. Alkyl, R is alkyl. nitration, and sulfonation. See, again, these reactions will be repeated in the next higher level. Electrophilic substitution reaction electrophilic substitution reaction, because electrophiles are going to substitute electrophilic substitution reaction in case of particularly benzene aromatic compounds madhya barutte. In the generation of electrophile, attack of electrophile, deprotonation, the hydrocarbons in the last part aromatic compounds madhya barutte. Halogenation, nitration, sulfonation. In addition to this, alkylation and acylation. Those two reactions are particularly known as Friedel-Crafts. Alkylation and Friedel-Crafts acylation. Two more name reactions. 5 electrophilic substitution reaction. Halogenation, nitration, sulfonation. Halogenation, nitration, sulfonation. Friedel-Crafts alkylation, Friedel-Crafts acylation. Not only in class 11, in class 12 also repeated in 3 or more functional groups. You 5 reactions repeat mechanisms only in class 11. In class 12, we won't explain the mechanisms directly, reactions, particularly for these 5 reactions. Okay, this is the first one. Substitution reaction is completed. Second one is oxidation. Oxidation means what? Addition of oxygen, or simply it is called as combustion reaction. Complete combustion, or simply oxidation. Complete oxidation, incomplete oxidation, catalytic oxidation. The second one is oxidation reaction. Oxidation reaction, or you can call it combustion reaction. Oxidation. Alkanes. Alkanes is nothing but hydrocarbons in general. When hydrocarbons undergo combustion, gives rise to the products. What are the products when hydrocarbons undergoing combustion? Carbon dioxide plus water plus some amount of energy will be liberated. So as it is, we can write the equation, balanced equations, very well the simple equations were called oxidation. In this total 3 reactions we are studying. Number 1, complete combustion or complete oxidation. Complete oxidation, or simply we can call combustion. Combustion is nothing but it is burned in the presence of oxygen, so oxygen will be added. It is an oxidation reaction. Combustion is also an oxidation reaction, or you can call complete oxidation reaction, complete combustion. So what happens here? Hydrocarbons. Simple example. First, let us take methane. When methane undergoing combustion, CH4 combustion happen basically oxygen. So when it undergoing combustion, this gives rise to the product carbon dioxide plus water plus some amount of energy. Now, how many carbons in the reactant? 1 carbon, so 1 carbon dioxide. How many hydrogens? 4 hydrogens. So therefore 4 hydrogens will become there 2 water molecules. 2 water molecules. Then how many oxygens are required? Total 4 oxygens are, because 2 plus 2 4. We'll already add it there. In add back 2 4 2. This is the balance equation. Can you write the equation for combustion of ethane? C2H6 plus O2 gives rise to CO2 plus H2O. How many carbons in the reactant side? 2 carbons, so 2 carbon dioxide. 6 hydrogen, so 3 water molecules. It's half. How many oxygens are required? H2O 7. 7, that means 3 by 2. 3.5. Correct? 3.5 molecules of O2 means double 7. Correct? Right. Next example, let us say butane C4 H10 plus it undergoing combustion, carbon dioxide plus water. How many carbon dioxide? 4. APPA. Because reactant said 4 carbon, 4 carbon dioxide. Water 5 water molecules. Reason 10 hydrogens are there, 10 hydrogen. Now balance oxygen. 2 4 are 8, 8 plus 5, 13. So 13 by 2, 13 by 2. So in general, CnH2n plus 2, alkane, alkane undergoing combustion. So this gives 3n plus 1 by 2 moles of oxygen. This gives rise to n number of carbon dioxide plus n plus 1 number of water molecules produced. Let's check. Butane n is equal to 4. N is equal to 4. So n is equal to 4. Extra करते हैं. काम हो रहा है 9 plus 1 13. 13 by 2. N is equal to 4. 4 is equal to 5s2. General equations for combustion reaction. General equation for combustion. This is complete combustion. Complete combustion means in the presence of sufficient amount of oxygen. If oxygen is sufficient, it undergoing complete combustion. If in the limited supply of oxygen, oxygen कमी पास में क्या ना देता है? Incomplete combustion. मैंने क्या सोचा होगा? ಯಾವ ಕಲರ್ ಇರುತ್ತೆ ರೆಡ್ ಕಲರ್ ಬರುತ್ತಾ ಪೂರ್ತಿ ರೆಡ್ ಬರಲ್ಲ ಬ್ಲೂ ಬರುತ್ತಾ ಇಲ್ಲ ನಿಮ್ಮನೆ ಬ್ಲೂನೇ ಬರಲ್ಲ ಈಗ ಸಿಲಿಂಡರ್ ಕಲರ್ ರೆಡ್ why it is blue complete combustion ಆದ್ರೆ suppose incomplete combustion ಆಯ್ತಂದ್ರೆ some red color ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತಾ red color incomplete combustion ಈ ಮನೆಯಲ್ಲಿ ದೀಪ ಹಚ್ಚಿರ್ತಾರೆ ನೋಡಿ ಸೀಮೆಣ್ಣೆ ದೀಪ ಯಾವ ಕಲರ್ ಇರ್ತದು ರೆಡ್ ಕಲರ್ ಮೇಲ್ಗಡೆ ಬ್ಲಾಕ್ ಸೂಟಿ ಫ್ಲೇಮ್ ಬರುತ್ತೆ ಬ್ಲಾಕ್ ಕಲರ್ ಪ್ರೂವ್ ಮಾಡುತ್ತೆ ಎಲ್ಲ ದೀಪ ಚಿತ್ರ ಮಾಡಲ್ಲ ಕರ್ರಗಾಗಿರ್ತಾರೆ ಮೇಲೆ ರೀಸನ್ ಎಸ್ಪೆಷಲಿ ದೇವ್ರ ಗುಡಿಗೆ ಹೋಗ್ಬಿಟ್ರು ನೋಡಿ ಆಂಜನೇಯ ದೇವಸ್ಥಾನಕ್ಕೆ ಹೋಗಿದ್ರೆ ಶನಿವಾರ ಬಂತಂದ್ರೆ ದೀಪ ಹಚ್ಚಿರ್ತಾರೆ ಮೇಲ್ಗಡೆ ಪೋರ್ಷನ್ ಎಲ್ಲ ಕರ್ರಗಾಗಿರುತ್ತೆ ಯಾಕ incomplete combustion carbon sooty flame so here incomplete combustion insufficient amount of oxygen that gives rise to incomplete combustion carbon monoxide or carbon. So, incomplete combustion. Incomplete combustion. In the presence of limited supply of oxygen. Limited supply. For example, methane. If sufficient amount means 2 moles of oxygen is required, if 2 moles of oxygen are not there. So then, incomplete, limited quantity, it gives either carbon monoxide, 1 carbon, carbon monoxide, 2 oxygens, 2 hydrogens, 2 H2. So 3 CO, carbon monoxide. Second possibility is if still it is less, then this gives rise to just carbon black and 2 water molecules. So it is 1 mole, 1.5, 2 moles. It is 1 mole, it is 1.5 mole. It is 2 mole. Sufficient means 2 moles gives us to complete carbon dioxide and water. If ಸ್ವಲ್ಪ oxygen quantity come madandre, there is a possibility of formation of carbon monoxide as well as carbon. In the limited supply of oxygen, which gives incomplete combustion, which gives us to sooty flame, that is carbon black, carbon or carbon monoxide. This is incomplete combustion. Now the third one is catalytic oxidation. This is the important one, catalytic oxidation. Important reaction, catalytic oxidation. So here, when methane undergoing oxidation, in the presence of methane undergoing oxidation, methane undergoing oxidation, CH4 plus O2. Pass out the okay, right? Combustion reaction clear? Combustion, complete combustion, sufficient oxygen ಬೇಕು. Incomplete combustion, if the oxygen content is less in the limited supply of oxygen, incomplete combustion. Now look at the catalytic oxidation. Methane undergoing oxidation. In the presence of, if I use copper around 573 Kelvin and 100 bar or 100 atmosphere. Copper, catalyst is copper. If we use copper as a catalyst, the product will be alcohol. The product will be alcohol. Product catalyst change करके so equation balance आएगा ना check कर लो. Yes. alcohol. Suppose if the catalyst is molybdenum oxide, MO2 O3, MO small o, capital M small o, molybdenum oxide. In this catalyst, which gives rise to aldehyde HCHO, CH2 the add hydrogens one over two hydrogen means H2. See the product in first case alcohol, second case aldehyde. If silver oxide is used, Az2O, Az2O, silver oxide, this gives rise to acid, COOH, COOH plus H2. Error plus 3 by 2. 3 by 2. That means, depending upon the catalyst used, the reagents which direct the reactions, which drive the reactions, ಯಾವ direction ಏನು product ಬರಬೇಕು ಅಂತ ಇದು ಡಿಸೈಡ್ ಮಾಡ್ತದೆ. If the catalyst is, if the reagent is copper, product is alcohol. Molybdenum oxide, product is aldehyde. Silver oxide, the product is acid, carboxylic acid. Second one, MO2 O3, MO, small o ಇದೆ, molybdenum oxide, molybdenum MO, small o ಬೇಕು, capital O ಬರೆದ್ರೆ ಇದು ಆಕ್ಸೈಡ್ ಆಗುತ್ತೆ, respective oxide, molybdenum oxide gives rise to aldehyde. So one case the product is alcohol, second case is aldehyde, next it is acid, carboxylic acid. So different products we are getting in the presence of different reagents. Catalytic oxidation. Second, oxidation reaction. Substitution, oxidation is complete. Next is there isomerization and aromatization pyrolysis. Last. Sound is there? One oxygen plus two oxygen, product three oxygen. So 3 moles make. 3 oxygen is only 3 oxygen means 1.5 O. 3 by 2 means what? 1.5. 1.5 O2 means 3 oxygen. Correct? 3 moles is raised to R oxygen agtave. Nascent oxygen 3 moles. 3 O2 is raised to 3 O2. 3 O2. It's by 2. By 2 is raised to only 3. 3 by 2 O2. The balance ಮಾಡ್ಕೊಳ್ಳೋದು book ಅಲ್ಲಿ ಯಾವ ತರ ಕೊಟ್ಟಿದ್ದಾರೆ multiply whole equation by 2 ಅವಾಗ ಏನಾಗುತ್ತೆ ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ 2 moles 4 this is the equation 3 by 2 ಫಾರ್ಮಲ್ ಕೊಡಂಗಿಲ್ಲ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಕೊಟ್ಟಿರ್ತಾರೆ so here it is 3 by 2 ಕೊಡಂಗಿಲ್ಲ 1.5 ತರ ಕೊಡಂಗಿಲ್ಲ ಡೆಸಿಮಲ್ so whole equation is multiplied by 2 so therefore it is get cancels 2 3 next 2 other equations ಕೊಟ್ಟಿರ್ತಾರೆ because 3 by 2 5 by 2 7 by 2 ಇಲ್ಲಿ ಯಾವ ತರ ಕೊಟ್ಟಿರ್ತಾರೆ ನೋಡಿ 7 by 2 ಇದು 7 ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ this is multiplied by 2 2 3 4 6 this is the balance equation na simple first simple ನ ಬರ್ಬಿಟ್ಟೆ ಈ ತರ ಕೊಡ್ತಾರೆ 7 ಯಾವ 7 ಆಗುತ್ತೆ 7 ಇದು ಕರೆಕ್ಟ್ ಇದೆ ತಪ್ಪಿದೆ ತಪ್ಪದ ಚೆಕ್ ಮಾಡ್ರಿ ಇದು 7 ಬರುತ್ತಾ ಹಾ ಟೋಟಲ್ ಎಷ್ಟು ಆಗುತ್ತೆ ಇಲ್ಲಿ 13 7 now get into 8 plus 6 14 so 14 means 7 ಮುಂಚೆ ಅಂತ ಬಂದಿದೆ ಇಲ್ಲಿ ಏನು ಬಂದಿದೆ ನನಗೆ 3 by 2 that is 7 by 2 7 by 2 ಬರೀರಿ ಟೋಟಲ್ 7 ಇತ್ತು 7 by 2 multiplied by 2 ಇದು multiply by 2 ಮಾಡಿದ್ರೆ ಕೆಳಗಿನ ಹೋಗ್ಬಿಡುತ್ತೆ final equations oxidation reactions next those 3 reactions will complete now isomerization reaction isomerization aromatization pyrolysis simple one definition isomer definition same molecular formula but differ in the structural formulas is known as isomerization correct for example if n butane N-butane structure CH3, CH2, CH2, CH3. N-butane. When it is converted into isobutane CH3, CH, CH3, CH3. Both are isomer. The reactions which involves change in the structural formula when the compound is heated in the presence of anhydrous aluminum chloride acid. Anhydrous AlCl3. Lewis acid in the presence of Lewis acid, which gives rise to isomers, means different structure. This reaction is called as isomerization. Yes. Heat. Symbol. N-pentane. When N-pentane undergoing isomerization gives rise to iso plus neo, different structure when the isomerization means changing its structure. Molecular formula there is change isomerization reaction. Anhydrous AlCl3. Anhydrous Al Lewis acid. So in the presence of this we get that is nothing but Lewis acid. What is meant by Lewis acid? AlCl3, FeCl3, FeBr3 ಯಾವುದು ಯೂಸ್ ಮಾಡ್ಕೊತೀವಿ. Lewis acid means acid base definition. Acid means what? H plus donor or OH minus acceptor acceptor OH minus donor base. In terms of electrons, can you define acid base? Electron donors are called as base. Electron acceptors are called acid. Electron acceptors are called as acid. Ammonia is a base. NH3 containing a lone pair. This has a tendency to give the electron. Electron donor are called base. Electron acceptor, electrons acceptor for example AlCl3 AlCl3 around the aluminum only 6 electrons are there, incomplete octet. It has 2 electron deficient to complete the octet, therefore it has a tendency to take 2 electrons. Electron acceptors are called as acids. Lewis acid in terms of Lewis in terms of electrons. Arrhenius acid base concept, Bronsted acid base concept, Lewis concept, equilibrium topic. ಮತ್ತೆ detail study ಮಾಡಿ. Acid base, pKa, pKb, pH, pOH calculations, numerical part, physical chemistry ಬರುತ್ತೆ. ಹೋಗ್ಬಿಡ ಅನ್ಸುತ್ತೆ. ಆಮೇಲೆ ನೋಡೋಣ. Yes, isomerization. Yes. Carbon. Single carbon. Carbon is single carbon. It is a reducing agent. All acid base ಯಾವುದು ಬರಂಗಿಲ್ಲ. Its oxide is acidic in nature. Oxides of carbon is acidic. Reason? Metal, non-metal. Metal oxides is base because when it is dissolved in water, it forms hydroxide. Non-metallic oxides are acidic in nature. Class 10. Metallic character across the period decreases, down the group increases. Oxides of metal, basic in nature, means basic nature across the period decreases, acidic nature increases across the period. Carbon is a non-metal. Its oxides are acidic in nature because when carbon dioxide dissolved in water, CO2 plus H2O, CO2 plus H2O, H2CO3, carbonic acid. Carbonic acid. So it is acidic in nature. Right. Next, aromatization. Formation of aromatic ring. Alkanes containing N is equal to 6 or more, 6 to 8 carbon atoms. The alkanes containing minimum 6 to 8 carbon atoms irrevocable. 6 to 8 ಅಂದ್ರೆ for example hexane, N-hexane, CH3, CH2, 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 CH3, 6 carbon atom. CH3, CH2 taken 4 times and CH3. Total is 6 carbon atom. When N-hexane, when it is reacted with the oxides of molybdenum oxide, MO2O3, chromic oxide, aluminium oxide in HCl, etc. when it is passed through a red hot tube at 773 Kelvin or approximately 800 Kelvin temperature. This is high temperature. So this undergoing aromatization, formation of a ring. First step, cyclization will take place. Cyclization is to R carbon is R carbon ring eliminate agakali. What is the elimination? 6 hydrogen agangilla initially. Ring agakandre only 2 hydrogens will be eliminated first. So here cyclohexane is produced in the first step. And under this condition, 3 moles of again hydrogens is removed, and this gives rise to a benzene ring. Benzene ring minus 3H2. First step cyclization, cyclic bond. Adad nanತರ ಮತ್ತೆ aromatic ring formation, aromatization. General ಆಗಿ ಈ terms skip ಮಾಡ್ತಿತ್ತು ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ. So direct ಬರ್ಕೊಳ್ಳೋದಾಗಂತ ಏನು aromatic benzene. This gives rise to benzene. When an alkane containing 6 to 8 carbon atoms, 6 to 8 carbon atoms, when it is heated at very high temperature in the presence of oxides of molybdenum, chromium or aluminum in a cell, gives rise to aromatic ring or aromatic compounds. This reaction is called aromatization. First time we must understand. If suppose 7 is 7 carbon atoms. No, 7 carbon atoms CH3, CH2, 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 CH3. 7 idava 1 2 3 4 5 6 7 CH2, CH2 remaining terminal are CH3 groups. When this undergoing aromatization, what happens? A ring is formed at this position. 6 member, not 7 members. 6 member ring. Benzene ring barbeku. Benzene ring barbeku. ಮೇಲ್ಗಡೆ ಒಂದು ಗ್ರೂಪ್ ಯಾವುದು CH3. So this is the product alkane. 6 ಇತ್ತಂದ್ರೆ ಡೈರೆಕ್ಟ್ ಬೆಂಜೀನ್. 7 ಇದ್ರೆ one group is substituted. 8 ಇತ್ತಂದ್ರೆ C2H5 is substituted. Again 6 membered ring form ಆಗುತ್ತೆ. Stable ring, 6 membered benzene ring, aromatic compound. So this is the aromatization. And the last reaction is pyrolysis. Cracking reaction or fragmentation reaction. ಏನಿಲ್ಲ ಅದನ್ನು ಸ್ಟ್ರಾಂಗ್ಲಿ ಹೀಟ್ ಮಾಡಬೇಕು in the presence of AlCl3. ದೊಡ್ಡ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಏನಾಗುತ್ತೆ ಪುಡಿ ಪುಡಿಯಾಗಿ ಸಣ್ಣ ಸಣ್ಣದಾಗಿ ಪುಡಿ ಪುಡಿಯಾಗಿ ಬರುತ್ತೆ. ಯಾವುದೋ ಒಂದು ಎನಿ ಒನ್ ಮೂರು ಆಕ್ಸೈಡ್ ತಗೊಂಡಿಲ್ಲ ಎನಿ ಒನ್ ಆಕ್ಸೈಡ್ಸ್ molybdenum oxide yes chromium oxides or aluminum oxide at high temperature red hot tube it forms aromatic ring. Oxides we ತಗೊಂಡಿರ್ತೀವಿ particularly D block elements na ತಗೊಂಡಿರ್ತೀವಿ. D block elements ಏನು ಇರ್ತಾವಲ್ಲ metals those are used as a catalyst because of variable oxidation state. D block elements behaves as a good catalyst, catalytic agents. Last reaction pyrolysis. Very simple enough ದೊಡ್ಡ ಕಾನ್ಸೆಪ್ಟ್ ಇಲ್ಲ. Pyrolysis reaction or it is simply called fragmentation, cracking reaction ಅಂತ ಕರೆದಿರ್ತೀವಿ ಅಂತಂದ್ರೆ fragmentation reaction or cracking reaction. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ ಸಿಂಪಲ್ ಬೇರೆ ಕಾಂಪೌಂಡ್ಸ್ n alkanes when it is heated at high temperature in the presence of like let me say AlCl3 which gives smaller molecules. For example, if suppose butane C4H10 n alkane when it is heated, what are the possibilities? It undergoing breakdown to give smaller molecules. Smaller molecules in the C4 ಇದೆ C2H6 ethane plus remaining ethane plus ethene alkenes are also produced because total molecular formula must be same C4H10 total C4 idava H idava 10 hexane C6H14 when it is undergoing cleavage gives rise to ಏನು ಬರಬಹುದು ಪ್ರಾಡಕ್ಟ್ ಏನು ಬರಬಹುದು ಎಲ್ಲ ಬರಬೇಕು at a time. First round CH4 plus ಏನು ಬರುತ್ತೆ other product C5H10 alkene plus methane ಇನ್ನು ಡಿಕಂಪೋಸ್ ಆಯ್ತು ಅಂದ್ರೆ ಏನು ಬರಬಹುದು ಇಲ್ಲಿ C2H6 plus dash you can write remaining C4H8. Again is as well C4H is as well suppose C3H6 पर अंदर प्लस ना देखो वो मतलब CH2 CH2 अपने और जो मॉलिक्यूल है एक्स्ट्रा देख लेते हैं ये जब तक C2H4 plus C2H4. So different smaller molecules are produced. When n alkanes is heated, strongly when it is heated in the presence of AlCl3, this gives rise to smaller molecules. And the dottu molecule chain break agi smaller molecules produce. Either it may forms double bond or triple bond. This reaction is known as fragmentation reaction or pyrolysis reaction or cracking reaction. This completes the chemical properties of alkanes. Next is a small concept is the conformations of the. After the conformations, next we'll move for alkanes in the next class. So what about that? Okay, right.